The nearest world beyond our own, that might hold a little life, is far closer than the edge of the galaxy, and far stranger than that nearness makes it sound. It is near the way a lighthouse across a wide bay is near, close enough to see and still a long dark water away. Tonight, we go looking for it, for the quiet worlds where water could stay liquid and life might once have gathered in the dark. Of the nearly 6,000 worlds we have found around other suns, only a small handful sit in the gentle ring where a sea could hold, and the closest of those is measured not in miles, but in years of light. Along the way we will settle three soft things into place. What lets a world keep water at all? A plain idea called the habitable zone. Then a slow tour of the nearest maybes, and last one a hopeful number to rest against at the close. If someone you love lies awake tonight, you might leave this quiet with them, for it is a gentle place to be left. Now let the room grow a shade darker, and let your breathing find its own slow level. There is nothing to reach and no one to be. Let's drift out. For a long time, the whole question had exactly one example to lean on: our own world. And a single case is a hard thing to reason from. That has quietly changed. In one human lifetime, the count of known worlds beyond our sun has gone from none at all to thousands, and the counting is not finished. Most of them are nothing like home, too scorched, or too frozen, or too airless for water to rest as a sea. But not all of them. A slow and growing handful fall into that narrow, forgiving band where a world can be warm enough and cool enough at once. And it is those we will drift toward tonight, unhurried, in no need of an answer. It is easy to carry an old and quiet picture of all this, the one most of us grew up with, in which the earth is the single green exception in an empty black room, and everything else is only rock and cold and silence. That picture is lovely in its way, but the sky has been telling us something softer and larger than that for a while now. The more carefully we have learned to look, the more the emptiness has filled in, gently, with the shapes of other possible homes. Where our grandparents saw only scattered points of light, we now see suns with worlds wheeling around them, and among those worlds a growing number that sit in just the right place for water. So we can set the old picture down tonight without any hurry, and let the fuller and kinder one drift slowly into view. Life, as far as anyone has ever been able to show, asks for very little to begin with, and yet that little turns out to be surprisingly particular. The one thing it seems to lean on again and again is liquid water, not ice locked hard as stone, and not vapor scattered thin into space, but water that can stay liquid and gather and pool and move. Everywhere on our own world that water stays liquid, from the warm shallows to the cold deep trenches to the thin films inside solid rock, some form of life has quietly moved in. So when astronomers go looking for other places that might hold life, they start by asking a very plain question. They wonder where, around a given star, a world could keep its water in that soft middle state, neither frozen nor risen away, but liquid and steady and free to move. Picture a star as a low and steady source of warmth in a very large, cold room. Stand too close to it, and the warmth is more than a world can hold. And any water it once had rises off into the dark as vapor. Drift too far away, and the warmth thins to almost nothing, and the water settles into ice that will not move again for ages. Somewhere between those two, though, there lies a comfortable ring of distance, where the warmth arrives just softly enough, and a world sitting inside that ring can cradle liquid water on its surface for a very long time. Astronomers call that comfortable ring the habitable zone, and long before they had a formal name for it, people were already calling it something friendlier and easier to hold. They called it the Goldilocks zone, after the old children's story of the porridge that was not too hot and not too cold, but just right. It is a gentle name for a gentle idea, and it holds up well. The zone is simply the band around a star where a rocky world could be, as the story says, just right for water. And the lovely thing about it is that every star has one. A bright and heavy star holds its comfortable ring far out, wide and distant, because it pours out so much warmth. Small and dim stars tuck their rings in close and snug, gathering their worlds near to feel what little warmth they give. Wherever there is a star burning steadily in the dark, there is a soft ring of possibility drawn around it, waiting to see whether any world happens to sit inside. Our own world sits almost exactly in the middle of the Sunday's comfortable ring, which is a large part of why the night you are resting in is possible at all. We are close enough that the water never freezes over entirely, and far enough that it never rises away, and so it stays, filling the low places, wrapping most of the planet in a thin blue skin of ocean. From far enough out in the dark, that ocean is the first thing you would notice about us. A small world gone soft and blue-gray with water, turning slowly under a thin veil of air. That, more or less, is the shape of the thing the whole search is looking for elsewhere. A modest rocky world with liquid water resting on its face in the gentle band around its star. The comfortable ring is only the beginning of the story, of course, and not the whole of it. A world can sit right in the middle of the zone and still be no place for water at all. If it has no air to hold the warmth in, or if it is too small to keep an ocean from drifting off into space, or too large and wrapped in crushing cloud. So the zone is best thought of as a first soft filter, a way of asking which worlds are even worth a longer look. It narrows a whole galaxy of stars down to the handful of places around each one, where the question of water, and therefore the question of life, is at least allowed to stay open. And once you have that gentle filter in hand, you can begin, at last, to count the worlds that pass through it. It helps to remember how forgiving life has turned out to be. Once water is present, we used to imagine it clinging only to mild and sunlit places, warm ponds and gentle shallows. Then, over the last handful of decades, we found it thriving in water, hot enough to steam, and in water near freezing beneath sheets of ice, and in cracks, in solid rock far below the ground, where no light has ever reached. Living things, it seems, will settle into almost any pocket of liquid water they are given, and hold on there patiently for as long as the water lasts. That single quiet fact widens the whole search enormously, because it means a world does not need to be soft and green and lovely to matter. It only needs, somewhere, a little water that stays. One might ask, quietly, why liquid water in particular, and not some other thing? Part of the answer is that water is a patient and generous host to chemistry. It dissolves a great many substances gently, and lets them drift and meet and mingle without tearing them apart, so that the slow reactions life depends on have room to happen and time to unfold. and water stays liquid across a comfortably wide range of warmth, wider than most simple liquids manage, which gives the world a broad margin in which it can hold its seas. None of this proves that life must use water, only that water makes an unusually welcoming cradle for it. So, when we search for water, we are really searching for the gentlest known place for chemistry to become something more. The comfortable ring does not stay fixed forever either, and that is a quiet part of the story too. A star brightens slowly over the long ages of its life, and as it brightens, its comfortable ring drifts gradually outward, away from the star. So, a world that sits in the ring today may have been too cold for water long ago, or may grow too warm for it far in the future. The band of possibility slides slowly outward across the ages, passing over one world and then the next, giving each its own long season in the light. Habitability, once again, turns out to be as much a matter of when as of where. A world's air can widen its chances more than its distance alone would suggest. And this is a quiet kindness of the way things work. Even a thick blanket of air holds a world's warmth in, the way a blanket holds your own warmth close on a cold night, so that a planet a little too far out for open water might still stay mild enough beneath a heavier sky. Give a cool world a generous atmosphere, and its seas can hold. Strip a warmer world bare, and its water flees. So the comfortable ring is not a hard and narrow line drawn in space, but a soft and blurred one that each world can nudge a little, inward or outward, by the sky it happens to wear. There is a second gentle thing worth carrying with us as we go. Alongside the idea of the ring, the stuff that living things are built from is not rare or special stardust, hoarded in one lucky corner of the sky. It is the most ordinary matter there is, the carbon and the water and the simple gases that form wherever stars have lived and ended and scattered themselves back into the dark. Those ingredients are spread everywhere, through every cloud and around every young star, laid down in the same proportions across the whole galaxy. So the raw makings of life are not the scarce part of the story. Wherever a world can keep its water liquid long enough, the ingredients are almost certainly already waiting there in the ground, and the air, common as dust, ready for whatever might come of them. For most of human history, the count of worlds around other stars stood, quite simply, at zero, not because there were none, but because we could not yet see them, and a thing you cannot see is easy to assume is not there. The stars were points of light and nothing more, and whether any of them held planets was a question people could only wonder about softly, without ever expecting an answer in their lifetimes. That long quiet lasted until almost the end of the last century, when the first true planet around another sun-like star was finally confirmed, and the count of known worlds beyond our own ticked over, for the very first time from none to one, a single confirmed world after all those ages of not knowing. It seems a small thing to say now, but it changed the sky. Once that first door was open, the others came quickly. Astronomers worked out clever and patient ways of noticing planets they could not photograph at all, mostly by watching their stars very carefully for tiny signs of company. A world passing in front of its star blocks a hair of its light, dimming it by a whisper, again and again, on a steady beat. Another world, circling its star, tugs it very gently to and fro, and that faint sway shows up as a small shift in the color of the starlight. Neither sign is dramatic. Both are almost impossibly small, far too small for any eye to catch. But the instruments grew patient and precise enough to read them at last, and once they could, the count of known worlds began to climb. Then came the space telescopes built for exactly this, watching quietly and without blinking. The Kepler telescope stared at a single patch of sky for years, holding more than 150,000 stars in its steady gaze at once, waiting for the faint repeated dimmings that betray a passing world. Later, the TESS telescope took up the same slow work across almost the whole sky, sweeping from one patch to the next, listening for the same small winks of shadow. Between those watchers above and the patient observers on the ground, the numbers grew from a handful to dozens to hundreds to thousands. And they are still climbing tonight, quietly, while you rest, as new worlds are checked and confirmed and added to the long and growing list. As of this year, the count of confirmed worlds around other stars stands at roughly 5,900. Every one of them is real, checked and rechecked. A genuine place with a genuine size and a genuine path around a genuine star. Some are giants of gas, larger than Jupiter, wrapped in banded cloud. Others are scorched and close to their suns, whipping around in a matter of days. A great many are cold and far or unfamiliar sizes we have no example of at home, and a small, precious fraction of them sit inside their star's comfortable ring in the soft band where water could stay. Nearly 6,000 known worlds where a single lifetime ago we knew of exactly none. That, more than any single planet, is the measure of how fast the dark has been filling in around us. It is worth sitting for a moment with how remarkable and recent all of this is. Everyone who lived before a few short decades ago went through their whole life without knowing, for certain, of one single other world beyond our own small family of planets. They looked up at the same stars we do and could only guess whether any of that light had worlds around it. We are among the very first people who get to look up and know, plainly and without doubt, that the sky is full of worlds, not as a hope and not as a story told to pass a long evening, but as a counted, catalogued fact, written down and checked. That knowledge is new enough that its newness has hardly worn off, and it is a quietly wonderful thing to be resting beneath tonight. And here is the gentlest part of the counting. Those nearly 6,000 worlds are only the ones we have managed to catch, and we can catch so very few. A world only dims its star for us if its path happens to carry it directly between that star and our small telescopes, which is a rare alignment, a matter of pure chance geometry. For every world lined up just right for us to notice, there are a great many more circling at angles that hide them from us entirely, going around and around, unseen. So the true count is not 6,000 at all. 6,000 is merely the number we have been lucky enough to see. The real number, waiting quietly behind the ones we have found, is something we will come back to softly at the close of the night. Each of these thousands of worlds began as nothing more than a faint pattern buried in a stream of numbers, a dip in a star's brightness, far too small to see with any eye. Someone, or some patient program, had to notice that dip and measure it, and watch for it to come again on the same steady beat, and rule out all the quieter things that might mimic a world before daring to call it one. Only then did a smudge of data become a place. It is slow and careful work, done far from any fanfare, and every name on the long list of worlds is the quiet reward of it. Behind each confirmed world stands a great deal of patient, unglamorous looking. Those worlds we have found are stranger and more varied than anyone quite expected before we began finding them. There are giant planets circling so close to their stars that they whip around in a day or two, their years shorter than our afternoons. Others are worlds larger than Earth, but smaller than Neptune, a whole common kind of planet that our own solar system happens not to have at all, so that we had no example of them at home. And there are worlds circling two suns at once, and worlds drifting far out in the long cold, each one a real place with its own particular nature. The sky, it turns out, was not built from our one familiar pattern, but from a great and gentle variety of them, and the counting has hardly slowed. New worlds are confirmed nearly every week now, sifted patiently from the faint records of the watching telescopes, by people working quietly at their screens, checking each candidate again and again before it is allowed onto the list. The catalogue that took all of history to begin now grows a little larger with each turning of the season. Somewhere tonight, while the sky is dark and most of the world is sleeping, another world around another star is being confirmed and written down, added to the long soft tally of the places that are really out there. The count you are resting beside is a living thing, still gently climbing. Before we drift onward, hold one more soft thought about those thousands of confirmed worlds. Every one of them is a real place, as real as the ground beneath you, with its own weather and its own long history and its own particular light in its sky. Somewhere out there, at this very moment, a small world is turning through its evening, and its star is sinking toward its horizon, and none of it needs a single watcher to go on happening. The catalogue we keep is only our own small record of a thing that was always there, doing what it does in the dark. We are not filling the sky with worlds by counting them. Only now, at long last, are we beginning to notice how full it always was. Before we drift out among the far stars, it is worth turning first to a world much closer to home, one you could see with your own eyes on a clear night as a small steady point, the color of old iron. Mars is a cold and quiet place today, a desert world smaller than our own, wrapped in a thin whisper of air too faint to hold much warmth. Its surface is dry, its skies are pale, and nothing moves there now but drifting dust and the slow turning of its seasons. And yet, Mars keeps, written plainly across its whole face, for anyone patient enough to read, the memory of a very different past when it was a far wetter and gentler world than the cold one we see now. When the spacecraft we have sent there look closely at the ground, they find the unmistakable handwriting of water almost everywhere they turn. There are long winding valleys, shaped exactly as rivers shape valleys, branching the way streams branch as they gather toward a sea. Wide flat basins lie where the floors of old lakes would be, ringed by the terraces that standing water leaves along a shore. Stones sit rounded smooth in the way that only long tumbling in a current can round them, and minerals rest in the soil that form only when rock soaks in water for a very long time. The land itself remembers rain. It remembers rivers and shorelines and standing water resting quietly under an open sky. Billions of years ago, it seems, Mars was a warmer and wetter world, with a thicker sky and liquid water pooling across its surface, rivers running down from its highlands, and perhaps a shallow sea spread across much of its northern half. For a stretch of time long enough to matter, Mars sat comfortably in the same soft category we are searching for tonight. A rocky world in its star's gentle ring, holding liquid water in the open air. Whether anything ever stirred to life in that ancient water we do not know, and may not know for a long while yet. But the water itself is not in doubt at all. It was there, and it was there for ages, long enough for a whole young world to grow familiar with the sound of rain. What became of all that water is a slower and quieter story, and a calm one to tell. Mars is a small world, and small worlds lose their grip on their air over enormous spans of time, letting it thin away into space breath by breath across the ages. As the air thinned, the warmth it once held leaked away with it, and the surface grew cold, and the water that did not escape as vapor sank into the ground and froze where it lay. Much of it is still there today, locked as ice beneath the surface and gathered thick and layered at the poles, patient and unmoving. A whole ancient ocean, in a sense, laid down to rest underground, waiting out the long cold of the world it once covered. Mars matters to a count of possible worlds for a simple and hopeful reason. It shows that a world does not have to stay in the comfortable ring forever to have had its chance at life. Habitability is not only a place, it is also a time, a window that can open for an age and then slowly close again. A world can drift through a long season of warmth and water and then cool quietly into stillness, keeping the whole record of what it once was folded carefully into its stones. And if that can happen next door to us, on the small point of iron light we can see with the naked eye, then it can surely happen out among the countless worlds we cannot see at all, over and over, on a scale we are only beginning to guess at. The layered ice gathered at the poles of Mars is itself a kind of quiet book, if you know how to read it. Each thin band was laid down in its own turn, as the world's long seasons and slow wobbles shifted the climate over ages, one pale layer resting gently upon the last. Together they hold a patient record of the world's changing weather, stretching back across enormous spans of time, written in ice instead of ink. To stand above those poles and look down would be to look at the memory of a whole world, pressed flat and stacked and kept frozen in the quiet. Even a cold and dry planet, it seems, keeps a careful diary of everything it has been. Mars also sits, as it happens, out near the cooler outer edge of the Sunday's own comfortable ring, rather than snug in the middle as we do. So, it has always lived closer to the cold margin, with less warmth to spare, which is part of why it slipped so far when its thick early air drained slowly away. It is a gentle cautionary tale, standing right beside us, a world that began with rivers and seas, much like a young Earth, and then, being smaller and cooler and more exposed, quietly lost its hold on them. The same soft rules that gave us our oceans set the limits that took away those of Mars, and both worlds obeyed them faithfully. There are hints, too, that Mars may not be entirely finished, with liquid water even now, in small and fleeting ways. Dark streaks appear on certain slopes as the seasons warm and fade again as they cool. And while their nature is still gently debated, some may be traces of briny water seeping thinly at the surface for a little while before vanishing. If so, then even today, on that cold and quiet world, water is not wholly a thing of the ancient past. It lingers, faint and occasional in the ground and along the sun-warmed slopes, a last soft echo of the seas that once filled the plains. The old wet world is gone, but it has not left entirely. Even now, though, Mars has not quite finished being interesting. Beneath its cold ground, in that buried ice, and in whatever thin films of liquid the deep warmth of the planet might still keep from freezing, there remain quiet pockets where life, if it ever took hold, could conceivably still be sheltering, slow and sparse, and hidden away from the dry surface. Nobody knows that anything is there. What we know is only that the door has not been fully closed, and that when we finally learn to read the deep places of that world, the answer, whichever way it falls, will be one of the gentlest and most patient things we have ever learned. For now, Mars turns in the cold, keeping its long memory of water, and we drift onward past it. From Mars we drift a little farther out, past the wide, quiet scattering of the asteroid belt, to the great banded giant Jupiter and the family of moons that circle it. And here the search for water takes a turn that surprised almost everyone when it first came clear, because it leads us not to a sunlit surface at all, but down into the dark, beneath a thick shell of ice. The moon in question is called Europa, a little smaller than our own moon, and from the outside it is one of the smoothest and palest things in the whole solar system. It is a bright sphere of ice wrapped in a fine web of faint reddish cracks, turning slowly in the cold, far from the warmth of the distant Sunday. Europa sits well outside its star's comfortable ring, far too distant to keep liquid water on any open surface. By the old rules, it should be nothing but a lifeless ball of ice, through and through, frozen solid to its heart. And yet the evidence has grown, patiently and from many separate directions, that beneath its frozen shell, kept liquid by a warmth that has nothing at all to do with sunlight, there lies a genuine ocean of salt water. Not a pond and not a buried lake, but a true ocean, wrapped all the way around the moon beneath its ice, holding, by careful estimate, more water than all the seas of our own world combined, a whole hidden sea, sealed away in the dark on a small moon of Jupiter. The warmth that keeps that ocean from freezing comes from a quiet and constant kneading. Europa circles a giant, and the giant's enormous pull stretches and squeezes the little moon very slightly as it goes around, flexing it the way you might slowly work a soft ball in your hand. That endless gentle flexing warms the moon's insides from within, without a single ray of sunlight ever reaching them. And it is enough, far out in the cold, to hold a whole ocean liquid beneath the ice. It is a wholly different way of keeping water than the comfortable ring provides, a way that does not care in the least how far the star may be, and it quietly opens the search to a great many places that the old rules had left out entirely. Think for a moment about what that ocean might be like if you could somehow drift softly down into it. There would be no light at all, only a deep and total dark, and a great weight of water pressing gently all around, and a ceiling of ice far overhead sealing it away from the sky. And yet, on our own world, we have found life thriving in almost exactly such places, in the lightless deep of our own oceans, gathered around cracks in the sea floor where warmth and minerals seep upward from below. Nothing there needs the Sunday at all. It lives on the plain chemistry of the rock and the water, patiently in the dark. If our own deep can hold life without light, then Europa's deep, warmed from within and steeped in salt, becomes a place worth wondering about very softly indeed. We are not guessing entirely in the dark about this ocean either. Spacecraft have flown close to Europa and read the moon's faint magnetic response, and the way it answers the giant's field is exactly the way a shell of salt water would answer, and quite unlike the way solid ice would. Telescopes have caught what may be faint plumes of water venting from the cracks, as though the hidden ocean occasionally sighs a little of itself up into space. And fresh missions are on their way there, even now, built to look far closer than we ever have before. In the years ahead, that pale, scarred moon may become one of the most carefully studied places in the whole solar system. All for the sake of the ocean it is quietly keeping in the dark. One of the quiet clues to Europa's ocean is written across its face for anyone to see. Its surface is remarkably smooth and young, with very few of the craters that scar older, deader worlds, as though the ice is being gently remade and resurfaced over and over across time. In places the crust looks broken into great pale rafts that seem to have shifted and drifted and settled again, the way slabs of sea ice move on an ocean at home. All of it hints at something soft and mobile beneath, a sea slowly working the ice from below, keeping the moon's face forever young. The world wears the signature of its hidden ocean quietly on the outside, and the flexing that warms Europa's ocean is not a small or gentle thing when you picture it whole. As the moon swings around its giant on a slightly stretched path, the entire crust rises and falls over and over by a real and measurable amount, breathing slowly beneath the ice. That endless rise and fall works the moon's interior like a kneaded thing, and the warmth it makes has kept the ocean liquid for a very long stretch of time, perhaps for most of the moon's whole existence. A little world, far from any sun, quietly warmed by nothing more than the patient rhythm of its own orbit. And Europa may not even be the only ocean in its own corner of the sky. Two of its larger sister moons around the same giant are thought, from what we have seen of them, to cradle buried oceans of their own, sealed deep beneath thicker shells of ice. If that holds true, then this single giant planet, far out beyond the comfortable ring, may keep not one hidden sea but three among its moons, a small quiet archipelago of oceans, circling in the cold, one giant, three possible seas. It is a gentle reminder that a single star may be keeping far more water in far more places than its one sunlit world would ever suggest. What Europa gives to our count is a whole new kind of world to add to it. Until we understood these ice-covered oceans, the search for life meant, more or less, the search for a mild sunlit surface in a narrow ring around a star. Now it means something wider and stranger and far more common, because moons like Europa need no comfortable ring at all. They can hold their oceans in the cold outer dark of any star system, warmed only by the steady pull of the giants they circle, wrapped and hidden and patient. And if such oceans are common, then the true tally of watery worlds is not set by the sunlit rings alone. It runs far out past them, into places we once wrote off entirely as too cold and too dark to matter. If Europa keeps its ocean a careful secret, the next world on our slow drift wears its ocean almost openly, and it is one of the loveliest things in all the sky. Farther out still, around the ringed giant Saturn, there circles a small bright moon called Enceladus, no wider across than a modest stretch of country, gleaming white with fresh, clean ice. For a long time, it seemed far too small and too cold to be anything more than a frozen pebble, one tidy snowball among the giant's many moons. Then, a spacecraft passing slowly through the Saturn system looked closely at its southern end and found the little moon doing something that almost nobody had thought to expect. From long cracks near its south pole, Enceladus is quietly spraying itself out into space. Great soft fountains of water vapor and fine ice rise continuously from those cracks, jetting up hundreds of miles above the surface, so much of it and so steadily that the little moon is slowly feeding one of Saturn's own faint outer rings with its own frozen breath. It is a gentle, ceaseless exhale of ocean water, thrown up into the cold and drifting slowly away, and it means that Enceladus, tiny as it is, must be carrying a liquid sea beneath its ice, just as Europa does, warmed from within by that same patient flexing. A moon you could nearly overlook, breathing its buried ocean out into the dark. The wonderful part is what those fountains quietly let us do. To sample the hidden ocean of Europa, we would have to somehow drill all the way down through miles of solid ice. But Enceladus lifts its ocean up and offers it freely to the sky, and the passing spacecraft was able to fly straight through the spray and taste it on the way past, without landing, without drilling, simply by gliding through the mist above a distant moon. It is as close to a gift as the outer solar system has ever handed us, a hidden sea rising up of its own accord to be read, held out to whatever might be passing by with the patience to notice. And what that spray turned out to hold was quietly astonishing. In the fine ice grains flung up from below, the instruments found salt of just the kind you would expect from an ocean in long contact with a rocky floor. They found the makings of the same simple chemistry that life leans on, and they found signs pointing to real warmth at the bottom of that ocean, to places where the water meets hot rock and minerals seep steadily upward, the very sort of place where life gathers in our own dark seas. In a few brief passes through a moon's frozen breath, we learned that a tiny world far from the Sunday holds a warm, salted, chemically rich ocean, exactly the kind of ocean where, here on Earth, life would not hesitate for a moment to settle in. None of this means that anything actually lives in the Sea of Enceladus. It means only that the Sea of Enceladus has, as far as anyone can yet tell, very nearly everything a small life would need: the water, the warmth, the salts, the steady chemistry, all of it gathered in the dark beneath the ice of a moon, so small you could hold its whole image on a fingertip at arm's length. That such a place should exist at all, so far from the Sunday, so easily overlooked, quietly reshapes the entire question we set out with. The ingredients of life turn out not to be rare and precious things, hoarded by a single lucky world. They lie around loose in the cold, in the hidden oceans of little moons, simply waiting to see what becomes of them. The cracks that Enceladus sprays from have a quiet grace to them, 4 long parallel fractures scored across its bright south pole, warm enough at the surface to feed the fountains above them. From those few slender lines, the whole ceaseless plume rises, gently and without pause, hour after hour and age after age. It is a wondrous and lovely thought that so much of a moon's inner ocean should find its way to the sky through so few narrow openings, like breath through a handful of held reeds. The little world exhales through those cracks continuously, feeding the dark around Saturn with a fine mist of its own frozen sea. Because Enceladus offers its ocean up so freely, it has become one of the places we most long to return to, and gently, to learn whether anything at all stirs in that hidden sea. We would not need to land or drill or disturb it in any way. We would need only to fly softly through the plume again, more slowly and with keener instruments than before, and read more finely what the fine ice grains are carrying up from below. The moon holds its own answer out into space, patiently for whoever comes next with the care to catch it. Few questions in all the sky are held so openly, or wait so quietly to be asked again. And there is a gentleness in how small the source of all this is. Enceladus is a modest thing, small enough that its whole surface would fit within a single one of our own countries. And yet it holds a warm, salted ocean and offers it freely to space. Size, it turns out, is no measure of what a world may be keeping. The grandest planets we have found may be barren, while a bright little moon you might overlook entirely cradles all the makings of life beneath its ice. It is a quiet lesson in not judging a world by how large it looms, and in looking closely always at the small and easily missed. Between them, Europa and Enceladus quietly change the shape of our count in a way worth holding on to as we drift onward. They tell us that when we tally the worlds that could hold life, we should not stop at the sunlit surfaces in the comfortable rings. We should count the buried oceans too, the ones sealed away under ice, warmed not by any star, but by the slow pull of the giants they circle. And those, it seems, may be far more numerous than the sunlit worlds ever were, tucked into the cold outer reaches of star system after star system. Each one, a small dark sea, patient and quiet and possibly not empty at all. From here, we drift out past the last of the great giants and turn our faces toward the other stars. There is one more world in our own family worth pausing beside. Before we leave it, because it does something so unlike all the others that it gently stretches the very idea of what a living world might be. Circling Saturn, along with the little fountains of Enceladus, there is a large moon named Titan, larger even than the planet Mercury, and it is the only moon in the whole solar system wrapped in a thick and heavy sky of its own. That sky is a soft hazy shade from within, dense enough to press down like deep water and to hide the surface entirely beneath a permanent veil of cloud. Under that veil, Titan is a world of rivers and seas and rain, remarkably like our own, but with one singular and beautiful difference that changes everything about it. On Titan, it is far too cold for water to be anything but rock-hard ice, as hard and unmoving as stone. So the rivers and lakes and rains there are not made of water at all. They are made of methane and ethane, gases we know as fuels on our own warm world, but which on frigid Titan flow instead as cold clear liquids. These cold liquids fill wide dark lakes near the moon's poles, run in slow rivers that carve winding valleys down through the ice, and fall, now and then, as a soft and unhurried rain. Titan has a full weather cycle of its own, clouds and rain and rivers and standing seas run entirely on a liquid that our own world could never keep in that form. It is the closest thing to Earth we have ever found, and yet its seas are not water. Whether anything could live in such a place is a question that pulls the imagination all the way to its quiet edge. Any life on Titan, if it exists there at all, could not be built the way ours is. It could not lean on water, could not work in any of the ways that everything we have ever met works. Such a life would have to take those cold liquid methane seas as its home fluid and run on a chemistry we have only barely begun to sketch out on paper. Most likely there is nothing living there at all. But the simple fact that we cannot yet rule it out, that a world so utterly unlike ours still keeps rivers and rain and standing seas and a slow patient weather of its own, gently widens the question we are asking yet again. It is worth resting a moment in how calm a place Titan is, for all its strangeness. The thick sky softens every shadow and blurs the light into a gentle, even glow, so that nothing there is harsh or sudden. Its rains fall slowly through the heavy air, drifting down more like a soft snow than any downpour. Rivers run gently there, the lakes lie still and mirror smooth, and the slow winds shape the dunes over ages without the least hurry. It is a world of patient weather under a muffled sky, keeping its quiet cycles far from anything quick. Of all the curious places we have found in the dark, few are as restful to picture as that hushed and hazy moon. Titan matters to our count, not because it is likely to be alive, but because of what it patiently teaches about how many ways a world can be. When we set out to tally the places that could hold life, it is easy to look only for near copies of Earth, small blue worlds with water oceans, in comfortable rings around ordinary stars. Titan quietly reminds us that nature does not limit itself to our one familiar recipe. It builds worlds with seas of the strangest liquids, weather driven by the strangest chemistry, all of it running smoothly, all of it stable across enormous spans of time. And if a moon in our own backyard can be this different and still this orderly, then the far worlds around other stars are surely stranger and more varied than any list we could ever write from here. So we leave our own small family of worlds, with the count already far larger and looser than we expected when we began. We started out thinking only of a single narrow ring around the Sunday, the one comfortable band where water could stay on an open surface. And in the slow drift out from there, we have found the memory of a lost sea on Mars, a living ocean hidden beneath the ice of Europa, another one breathing softly up from the cracks of Enceladus, and a whole world of cold rivers and rain on Titan, running on a liquid we never once thought to include. 4 or 5 more places to wonder about, all of them within reach of the little craft we have already sent, all of them found within a single human lifetime, all of them circling one ordinary star. We did not have to guess entirely at what lies beneath Titan's veil. For once, a small craft was sent drifting down through that thick sky to sea. It fell slowly on a wide parachute through the haze, and as it descended, it saw the land resolve below it. Dark drainage channels winding down from pale highlands toward what looked for all the world like a shoreline. The craft came to rest at last on a plain scattered with rounded pebbles, stones smoothed by liquid, just as river stones are smoothed at home. For a few quiet hours, it sent back what it saw from the surface of a moon almost 1 billion miles away, and what it saw was a shore. Titan turns through long, slow seasons of its own, each one lasting many of our years. And as they turn, the weather shifts across its face. Clouds gather over one pole and then the other. Rains come and go. The great methane lakes swell a little and then draw back. Wide fields of dark dunes stretch across its middle, shaped by slow winds into long parallel ridges, patient and orderly. It is a fully working world with its own climate and its own quiet cycles, running smoothly on a chemistry entirely unlike ours. And it has been running that way, undisturbed and unwatched, since long before anyone was here to imagine it. This is only our own star, though one plain and ordinary star, among a great uncounted multitude of them. If a single sun can gather around itself this much water and this many maybes, one comfortable world, one remembering desert, two hidden oceans, one reigning moon, then the whole vast field of other suns must be doing something very like the same thing, over and over, in ways we will never fully catalogue. So from here, we lift our gaze off our own small family entirely and out across the enormous quiet dark toward the very nearest of those other stars and the worlds that have begun to appear around them. The drift widens now out from a single star system into the long reaches between the stars themselves. That gulf between the stars is wider than almost anything the mind can hold, and it is worth letting its width settle gently over you before we cross it. Our own Sunday and its family float in a great emptiness, and the very nearest other star to us lies so far off that its light, moving at the fastest speed there is, takes more than 4 years to cross the distance and reach us. That star is called Proxima Centauri, and the light of it arriving tonight, this very light, left it more than 4 years ago, back when your own life was in a somewhat different chapter than the one you are in now. 4.2 light years, we say, as though it were a tidy and manageable distance. It is the closest doorstep in all the sky, and it is still almost unimaginably far away. Proxima Centauri is a small and dim star, what astronomers call a red dwarf, far cooler and fainter than our own Sunday, giving off only a modest ember of light and warmth into the dark around it. For a long time, such small stars were quietly passed over in the search for worlds, thought too faint and too feeble to bother with. And then, circling that very nearest of all the stars, astronomers found a planet, a world of roughly our own size, rocky and solid, and, most quietly wonderful of all, sitting right inside the star's comfortable ring. They named it Proxima Centauri b, and it remains, to this day, the closest world beyond our own solar system that could, conceivably, hold liquid water on its surface. The nearest maybe in the entire sky happens to orbit the nearest star in the entire sky. Because Proxima is such a dim and gentle star, its comfortable ring is drawn in very close, far closer than the wide ring around our own Sunday. So Proxima Centauri b hugs its star tightly, completing a whole year, one full circle around its sun, in only about 11 of our days. Picture that softly for a moment, without doing any arithmetic at all. Here is a world where a year is shorter than a fortnight, where the seasons, if it has any seasons, turn over and over again, while a single one of our months slips quietly past. It is a small, close world, circling a small, cool star, held in a quick and tidy orbit, warmed just enough, perhaps, to keep a little water liquid somewhere across its face. We must hold the maybe of Proxima Centauri b very gently, because there is a great deal we simply cannot see from 4 light-years away. Its rough size and its distance from its star, we do know enough to place it, hopefully, within the comfortable ring where water is allowed. Whether it kept an atmosphere or lost one long ago, whether water pools anywhere across its surface, whether its close cool star treats it kindly across the long ages, all of this stays out of our reach for now. A red dwarf can be a restless sort of companion, given now and then to sudden flares of light that wash over a world held so near. Proxima Centauri b sits in the soft band where water is permitted, but whether it has made anything of that permission, we simply do not yet know. Even so, there is something deeply steadying about that world, quite apart from whether it turns out to be truly habitable. It tells us that we did not have to look very far at all. The very first star out our own door, the nearest of all the countless suns, turned out to have a world of roughly our size sitting quietly in its comfortable ring. If the closest star we have has such a world, then such worlds cannot be rare or precious things, scattered thin and far between across the whole galaxy. They must instead be common, ordinary, lying near to hand around star after star after star. We reached out toward the very nearest star, almost at random, and found a maybe already waiting there for us. That is not the sky of a lonely universe. Proxima does not drift through the dark entirely by itself, as it happens. It is the small and distant third member of a little family of stars, circling far out around a close pair of brighter suns that together we call Alpha Centauri, the nearest bright star to our own. So, the closest stellar neighborhood we have is not a single lonely light, but a gentle gathering of 3 suns, bound loosely together, drifting through the galaxy as a group, and around the smallest and dimmest of them, tucked in close, sits the nearest maybe of all. Even our very nearest patch of the sky, it turns out, is more crowded and companionable than the old empty picture ever allowed. The planet itself was found not by seeing it, but by feeling its gentle pull upon its star. Astronomers watched the light of Proxima with great patience and noticed the faint, regular sway of the star being tugged first a little one way and then the other, over and over, on an 11-day rhythm. That soft repeating pull could only be the hand of an unseen world, circling close, drawing its star gently to and fro as it went. So we knew the world was there, and roughly how large, before we ever caught a glimpse of it, read entirely from the quiet, swaying of a distant point of light. It is a delicate way to find a world, and a patient one. One begins to feel, softly, just how far 4 light-years really is, and how near. Far enough that no craft we have ever built could cross it in less than tens of thousands of years, so that reaching it stays, for now, a thing of the distant imagination rather than of any plan. And yet, near enough, in the great scheme of the galaxy, that we can already study its faint light, weigh its unseen world, and dream in detail of what might rest there. It is the rare gift of this moment that a place can be at once entirely beyond our reach and fully within our sight, close enough to know and far too far to touch. And Proxima Centauri b is only the beginning of what its kind of star has to offer, because those small dim red stars once quietly passed over, turn out to be the most common stars in the entire galaxy by a very wide margin. For every star, like our own Sunday, there are several of these small, cool embers, burning low and slow and patient. Most of the stars in the sky, most of the suns in the whole vast turning wheel of the galaxy, are exactly the same sort of star that Proxima is. So the worlds we find in their comfortable rings are not some curiosity at the edge of the search. They may, in fact, be the very heart of it. And to understand them, we have to picture what it is like to be a world circling so close to so small a sun, which is the strangest and gentlest place our whole drift will take us tonight. To sit in the comfortable ring of a small red star is to live in a very different way than we do. And it is here, in the deep and quiet middle of the night, that our drift finds its strangest and most beautiful country. Because a red dwarf gives off so little warmth, any world close enough to keep its water must lie very near the star, tucked in tight against it. And a world held that close does something our own spinning world does not. Over long ages the star's steady pull slows the world's turning, gently and then completely, until at last it turns exactly once for every single circle it makes, and so keeps one face always toward its star, and one face always toward the dark. Astronomers call this being tidally locked, and it makes for a world quite unlike any we have ever stood upon. Imagine such a place softly, as though you were looking down on it from far above. On one side, there lies a perpetual day that never moves, the small red sun hanging forever in the same fixed spot in the sky, never rising and never setting, pouring its dim, steady light down onto a single, unchanging half of the world. The other side holds a perpetual night that never lifts, a dark hemisphere that has never once seen its star, resting always beneath a sky full only of the distant colder stars far beyond. No dawn ever crosses that world, and no evening ever falls upon it. Day stays day, and night stays night, and the whole sky simply holds itself perfectly still, age after age, without ever once turning. You might well think a world split so completely between endless day and endless night could be no place for water or for life at all, one half held bright and one half locked in cold. And for a long while, that is very nearly what astronomers feared about them. But the closer they looked, and the more carefully they modeled these worlds on their machines, the gentler and more forgiving the picture slowly became. A world with any air at all, or any ocean, does not simply let its two halves sit forever at their opposite extremes. The air moves, carrying warmth from the bright side around toward the dark. Any ocean, if there is one, does the very same thing beneath, smoothing the difference, sharing the warmth around, softening what would otherwise be a hard divide into something far more livable and mild. And there is one region of such a world that draws the imagination more than any other, a place with a quiet and lovely name. All the way around, a tidally locked world, in a great encircling ring, there runs the border between the endless day and the endless night, the line where the small sun sits always resting on the horizon, neither risen nor set. Astronomers call this the Terminator, and along that whole encircling band, there stretches a soft, perpetual twilight, an unending dusk that never deepens into night and never brightens into day. Not the fuller light of the day side, and not the deep cold of the night side, but a still and gentle in between, drawn all the way around the world like a ribbon of endless evening. It is along that ribbon of endless dusk, if anywhere, that a red dwarf world might be most welcoming to a little life. There, the star hangs low and soft on the horizon forever, its dim light slanting gently across the land, never harsh and never wholly gone. Along that same band, the warmth carried around from the day side meets the cool creeping in from the night side, and the two settle together into a mild and steady balance. If water pools anywhere on such a world, if life takes any hold at all, it may well gather along that quiet twilit band, in a ring of perpetual evening, wrapped all the way around a still and silent world. It is one of the strangest and most peaceful pictures the whole long search has ever handed us to hold. There is one gentle catch to living beside a small red star, and it is worth naming softly and then setting quietly aside. These little stars in their long youth can be a restless sort, sending out sudden bright flares of light and particles that wash over any world held so close against them. A world sitting in a red dwarf's comfortable ring rests near enough to feel those flares fully, and over ages that could wear away an unprotected atmosphere or trouble whatever chemistry is trying to begin down on the surface. Whether a given world weathers, all this depends on things we cannot yet see from here, on its air and its own magnetic shielding, and the particular temper of its particular star. So the red dwarf worlds are maybes with a soft question folded up inside them, hopeful and uncertain at the very same time. There is a further gift these small red stars quietly offer, and it is the gift of time. A star like our own Sunday burns brightly, and by the measure of the cosmos, rather quickly, lasting some 10 billion years before its long middle age is done. But the small red dwarfs burn so low and so sparingly that they can go on shining steadily, not for billions of years, but for trillions, far longer than the universe has yet existed. A world circling such a star has almost limitless time laid out before it, ages upon ages of quiet, steady warmth in which slow things might unfold. If patience is what life needs above all, then the small red suns offer more of it than any other place in the sky. Picture one of these worlds whole, the way our machines have taught us to imagine them, and a gentle shape appears. The face turned always toward the star might hold a single wide warm sea, a great round eye of open water beneath the fixed low sun, while the far cold night side lies wrapped in a cap of ice that never melts. Between them runs that soft ring of endless dusk. Some have taken to calling such a place an eye world, for the great round ocean staring forever up at its small red sun. It is one of the tenderest pictures the whole search has drawn, a still world with a single sea for an eye, gazing quietly at its patient star. And there is a rare steadiness to life beside such a star, a smoothness that our own restless world has never known. With one face held always toward the sun and no turning to bring on day and night, a locked world feels no dawn and no dusk, no sharp turning of the seasons. None of the constant changes our own spinning brings us. Its warmth arrives always from the very same low quarter of the sky, unwavering, age upon age. Whatever might gather there would know a calm our world has never once offered, a light that never rises and never sets, a warmth that never wavers or fades. For a slow and patient kind of life, that deep changelessness might be the gentlest cradle of all. There is a quiet beauty too in the color of the light such a world would rest beneath, A red dwarf shines with a deep and gentle red, far softer than our own white daylight, so that a world circling one would lie under a dim, ruddy glow that never brightens to the fierce noon we know. Its perpetual day would be a kind of endless red evening, calm and low and easy on the eyes. The small sun sitting quiet on the horizon, whatever might one day gather on such a world, would know only that soft red light, steady and unchanging, pouring gently down across a still and silent land for age upon age. But set that uncertainty gently to one side for a moment, and simply look at the sheer number of these worlds. Small red stars are the most common stars there are anywhere, filling the galaxy in their countless billions, each one drawing its own snug, comfortable ring, each ring able to hold its own quiet world. Even if only some fraction of those worlds keep their air and their water through the long ages, the fraction is drawn from so vast a pool of stars that the count of possible homes climbs into numbers the mind can barely follow. The far, still worlds of the small red suns, with their fixed sunlight and their rings of endless dusk, may well be the most numerous places in the entire galaxy where water could rest and a little life could gather. That deepest and quietest part of our night is also, it turns out, the most crowded with maybes. If you would like a single place that gathers up everything we have been drifting through, everything about small red stars and close worlds and comfortable rings, there is one star system that holds it all in a single tidy handful, and it is among the most quietly astonishing things ever found. About 40 light years from here, a distance still far too great to truly picture, but close enough at last to study carefully, there burns a very small and very cool red star with a plain, unmemorable name, a star known as TRAPPIST-1. It is barely larger across than the giant planet Jupiter, dim and low and slow. And circling that one small star, packed in surprisingly close around it, there are not one or two worlds, but seven whole rocky worlds around a single small sun. Every one of those 7 worlds is roughly the size of our own, rocky and solid underfoot, and they are gathered so tightly around their small dim star that all 7 of them together would fit comfortably inside the orbit of our own innermost planet. They circle in quick, close, orderly paths, their whole years measured in mere days, tucked in near their gentle sun, because that is the only place its faint warmth can reach. From the surface of any one of them, the others would sometimes hang large and clear in the sky, close enough to show as real worlds rather than mere points of light, a whole family of neighbors drifting past one another in a slow and stately dance overhead. It is a crowded and companionable little system, spinning quietly around its small red sun. And here is the part that draws every eye toward this small far system. Of those 7 worlds, several sit squarely inside the star's comfortable ring, in the soft band where liquid water could stay. Not one lucky planet in the zone, as we have around our own Sunday, but 3 or 4 of them at once, clustered together around a single small star, each one a rocky world of roughly Earth size, resting in the place where water is allowed. It is very nearly as though the whole search handed us, in one small system, 40 light years off, a whole row of maybes lined up neatly side by side, ready to be studied one after another as our instruments slowly grow keen enough to read them properly. These 7 worlds have become some of the most watched places in all the sky, and for very good reason. Because those planets pass directly in front of their star as they orbit, they dim its light a little in a way we can read from here, and each faint dimming carries, if we look carefully enough at it, a trace of whatever thin air the passing world may hold around itself. So this small, far system has quietly become a kind of proving ground, a place where we are learning patiently and for the very first time how to weigh the atmospheres of rocky worlds, the size of our own, around another star entirely. Whatever we come to understand about worlds like ours out there in the dark, a good deal of it will very likely be learned first at TRAPPIST-1. It is worth holding the whole picture of that little system in your mind for a moment. Softly, the way you might hold a snow globe up to the last of the light. One small cool star, no brighter to the eye than a distant lamp. 7 rocky worlds gathered close around it in quick and orderly orbits. 3 or 4 of them resting within the comfortable ring, wrapped perhaps in air, holding perhaps a little water somewhere, each of them with its neighbors hanging large and clear in its sky. A whole compact system of possible homes, complete and self-contained, 40 light-years away, doing exactly what it has always done, entirely without us, entirely without any need to be watched at all. And we simply happen to be alive at the one moment we can finally begin to see it. The 7 worlds move around their small sun in a quiet kind of harmony, their orbits tuned to one another in simple whole number rhythms, so that each completes its year in gentle step with its neighbors. As one world circles twice, another circles 3 times, and another still keeps its own matching beat, the whole system turning like a slow piece of clockwork that has kept its time for ages. Astronomers can hear that harmony in the numbers, a soft mathematical music written into the orbits themselves. It is a delicate arrangement, and its very delicacy is part of why the system has stayed so orderly and so stable across all its long existence. This little system was first noticed from the ground by a modest telescope watching for the faint winks of worlds crossing their star, and only later studied closely from above. Once the watching telescopes in space turned toward it, the full family came clear, world by world, until all 7 were counted, and their sizes gently weighed. That so rich a system was hiding around so dim and unremarkable a star. One we might easily have passed over is its own quiet lesson. The most rewarding places are not always the brightest ones. Sometimes the small, dim, overlooked star is the very one cradling a whole row of worlds in its comfortable ring. Think, for a last soft moment, of standing on one of those 7 worlds and looking up. The neighbors would not be distant points of light as our own planets are, faint and lost among the stars. They would hang large and near in the sky, showing as real worlds with real faces, growing and shrinking, as they and you drifted along your close orbits, sometimes crossing slowly in front of the small red sun. It would be a companionable sort of sky, crowded and near and always gently changing, a family of worlds forever in view of one another. Whatever the truth of those 7 turns out to be, the mere picture of that shared sky is a warm one to carry down towards sleep. What this crowded little system gives to our count is a plain lesson in abundance close to hand. If a single small and ordinary red star, one of the most common kinds of star there is, can gather up 7 rocky worlds and set 3 or 4 of them squarely in its comfortable ring, then the comfortable rings of the galaxy are not lonely places at all, each holding a single planet, if if it happens to be lucky. They can instead be full, quietly crowded with worlds, several maybes to a star. Multiply that gentle abundance across the countless small red stars we have already met tonight, and the tally of possible homes does not merely grow a little. It begins to feel less like a rare treasure to be hunted for, and more like a plain feature of the sky, as ordinary and everywhere as the stars themselves. From this small crowded system, we drift on to worlds farther still, around stars far more like our own. Not every promising world circles a small red star as it happens. Some of the gentlest maybes we have found so far orbit stars a great deal, more like our own Sunday, farther away from us and harder to reach, but for that very reason closer in kind to the world you are resting on tonight. These are the distant cousins, worlds that would feel, in their broad outlines, more familiar to us than the tidally locked worlds of the small red suns. And two of them in particular, both patiently found by the long staring of the Kepler telescope, are well worth drifting all the way out to visit before the night grows late and we begin to turn softly homeward. The first is a world named Kepler 186f, some 500 light-years off, circling a star that is cooler and dimmer than our Sunday, but not nearly so small and faint as the red dwarfs we have been visiting. Kepler 186f is only a little larger than our own world, rocky and solid, and it sits out near the cooler outer edge of its star's comfortable ring, in that part of the band where liquid water could still, with a helping hand from a thick enough atmosphere, manage to remain. It was among the first worlds close to Earth's own size, ever found within a comfortable ring around another star, and its quiet discovery gently proved that such worlds were genuinely out there to be found at all, and not merely hoped for in the dark. The second of them, and perhaps the more tantalizing to think about, is a world called Kepler 442b, a little over 1,000 light-years away, somewhat larger than ours and circling a star just a touch cooler than the Sunday. Of all the worlds we have found so far around, distant sun-like stars, Kepler 442b is among the very best placed of any of them, sitting comfortably within its star's ring and receiving a soft amount of warmth, not so very far from what our own world receives from the Sunday. It is what astronomers sometimes call a super-Earth, a rocky world, a single step larger than our own. And if it holds onto air and water, its surface may be one of the more genuinely welcoming places we have yet found, anywhere in all the sky. We must be careful and gentle with worlds such as these, because their great distance keeps them dim and terribly hard to read. Across 500 or 1,000 light-years, we can measure a world's rough size and its orbit, and the warmth it likely receives from its star, and precious little more than that. Whether Kepler 186f or Kepler 442b actually holds an atmosphere at all, whether water truly pools anywhere upon either of them, whether anything whatever stirs in that water are questions their sheer distance keeps softly out of our reach for now. They are maybes held far out at arm's length, farther than we can yet examine closely, but they are real worlds all the same, of roughly the right size, in roughly the right place, around roughly the right kind of star, and that alone is a quiet marvel to sit with. What makes the distant cousins truly matter is not that we can study them well, because we plainly cannot, at least not yet. It is what the two of them quietly stand for. Kepler 186f and Kepler 442b are proof, found and confirmed and written down, that the comfortable rings of ordinary sun-like stars, stars of the very same broad family as our own, hold rocky worlds of nearly our own size, sitting in the soft band where water is allowed to stay. It is not only the small red stars that have their maybes. The stars most like our own Sunday have them too, scattered out through the great distances, waiting in comfortable rings of their own. And there are a very great many stars like the Sunday. So behind these two named worlds, there must stand an unseen multitude of others, just like them, undiscovered only because they are far and dim and did not happen to pass in front of their stars for us to notice. It is worth remembering how these far cousins were found at all, because it says something gentle about patience. The Kepler telescope did nothing dramatic. It simply stared, without pause, at one single patch of sky for years on end, watching more than 100,000 stars at once and waiting for the faint repeated dimming of a world crossing its star's face. A single crossing was never enough. The telescope had to wait for a world to come around again and again before it could be trusted, so that finding a world in a wide, comfortable orbit meant waiting through year after patient year. Its whole harvest of distant worlds was gathered by nothing more than looking steadily and refusing to look away. And the patch of sky that Kepler watched so faithfully was only a small one, a single narrow window held open on the vastness, no wider to the eye than a hand raised against the night. All those thousands of worlds were gathered from that one modest square of stars alone. Turn that same patient gaze toward any other patch of the sky, and another such harvest would surely follow. And another beyond that, in every direction there is. The worlds Kepler found are not the sky's whole crop, but a single small sample of it, taken through one narrow window. Behind that window stands the rest of the sky, unwatched and just as full. And though we cannot yet study these far worlds closely, their real value lies in what they let us calculate. From the fraction of stars that Kepler found to carry a world in the comfortable ring, astronomers could reason outward to all the stars it could not see, and estimate how common such worlds must be across the whole galaxy. So each distant cousin is not only a place in its own right, but a single counted sample standing in for a vast unseen multitude. The two named worlds we can point to are the small visible tip of something enormous, a gentle proof that the comfortable rings of sun-like stars are more often than not quietly occupied. So the distant cousins gently close a small circle in our thinking tonight. We began by finding water and maybes all through our own solar system, around our single ordinary star. From there, we drifted out to the nearest star and found a world resting in its ring, and out among the common red dwarfs found their crowded rings full of locked twilight worlds. And now, around the stars most like our own Sunday, we find rocky worlds of nearly our own size, resting quietly where water could stay. Every single kind of star we have looked at closely tonight, from the smallest dim ember to a near twin of our own Sunday, has offered up its maybes to us. The pattern holds wherever we happen to turn. And that steady, repeating pattern is exactly what lets us do the last and gentlest thing of the night, which is to stop counting the worlds one by one and begin, softly, to count them all at once. There is a question that has been hovering quietly behind everything we have counted tonight, and it is the softest and most patient question there is. Finding a world resting in a comfortable ring tells us only that water could be there. It does not tell us that anything actually is. To move from could to is we would need to somehow reach across all those light years and learn what a distant world is truly made of, what its air holds, whether anything living has left its faint mark anywhere upon it. For almost the whole of history that seemed forever and completely out of reach. And then, in just the last few years, very quietly, it has begun to become possible after all. The trick of it is a gentle and rather beautiful one. When a world passes in front of its star, a little of the star's light does not simply get blocked away. A thin sliver of it filters through the ring of atmosphere around the world's edge on its way toward us. And as it passes through that air, the gases there quietly drink up particular colors of the light, each kind of gas leaving its own faint fingerprint pressed carefully into the beam. So, if we can only catch and spread out that filtered starlight finely enough, we can read in the exact colors that are missing from it the very gases in the air of a world we will almost certainly never visit. The atmosphere writes its own name into the passing light, and we have at last built an instrument patient and precise enough to read it back. That instrument is the Great Space Telescope named for James Webb, drifting far from Earth out in the cold and the dark, its huge mirror unfolded to catch the very faintest infrared light. Webb was built, among many other things, for exactly this delicate and painstaking work, for spreading out the thin thread of starlight that has passed through an alien atmosphere and reading the gases quietly written there. And in the short time since it first opened its eye upon the sky, it has begun to do what no instrument before it ever could, weighing the airs of distant worlds, one careful measurement at a time, gently, across distances so vast that they make the mind go quiet just to hold them. A telescope reading the air of a world it will never touch. One world in particular has drawn a great deal of soft attention in recent years, a world named K218b, a bit over 100 light-years away, larger than Earth, and circling within its cool star's comfortable ring. When Webb spread out the starlight that had filtered through its atmosphere, it found signs of a few familiar gases, and then, more faintly still and far more carefully, a possible hint of a gas that, here on our own world, is made almost entirely by living things. It was the barest whisper of a signal, held up with the very greatest of caution, and it set the quiet corners of astronomy gently alight with wonder and with careful, hopeful argument. That whisper must be held very gently indeed, and the astronomers who first found it are the very first to say so. A faint possible trace of a single gas, read across 100 light-years of empty space, right at the trembling edge of what even our finest instrument can detect, is simply not a discovery of life. It is a hint, unconfirmed, that will need a great many more careful measurements before anyone at all can say what it truly means. And there are quiet, ordinary explanations for it that have nothing whatever to do with life. The signal may well fade away under closer study as tentative signals so often do. Or it may slowly firm up over the coming years into something more. Nobody yet knows which, and the not knowing is a real part of the wonder, and not a flaw in it at all. What would truly convince us is not one lonely gas, but a gentle disagreement of them. On our own world, the air holds gases that ought not to linger together, kept in their odd mixture only by the constant quiet work of living things replenishing them. If we were to read, in the air of a distant world, two such gases coexisting where they should long ago have cancelled one another out, that steady imbalance would be a soft, but powerful sign that something was busily remaking the air. No single measurement would settle it, but a whole world's air caught in a balance it could not hold on its own would be about as gentle and as telling a clue as the sky could offer. And we are only at the very beginning of this listening. The telescope reading these airs today is the first of its kind, and larger and keener instruments are already being dreamed and built to follow it. Machines designed to catch the still fainter breath of still smaller worlds. It may take many years and many patient measurements, and more than one generation of watchers before any of it is settled one way or another. But the door that was closed for all of history is open now, even if only by a crack, and through it a little light is coming. We have begun, at last, the slow and gentle work of learning what the distant worlds are made of. It is worth holding our search loosely too, and keeping room in it for surprise. We look, quite naturally, for worlds like our own, and for life built the way ours is built, because that is the one example we have to reason from. But the reigning seas of Titan already hint that nature may work in ways we have not thought to look for, with other liquids and other chemistries, in places we might too quickly call empty. So the honest searcher keeps one eye on the familiar and one gently open to the unfamiliar, ready to be surprised by a kind of world or a kind of life that fits none of our expectations. The sky has been wider than we guessed at every turn so far. But set aside, just for a moment, whether this one particular whisper holds or fades. The deeper marvel is simply that we can hear any whispers at all. For the whole long stretch of human history, the air of another world was something no one alive could ever hope to know. Now, quietly, from a single cold telescope drifting far out in the dark, we are beginning to read the atmospheres of worlds 100 light years away, gas by patient gas, looking for the faint chemical traces that life would leave behind it. We have not yet found life anywhere at all, but here at home. Yet for the very first time we have built the ears to listen for it, and we have turned those ears toward the maybes, and we have begun, ever so gently, to hear the airs of distant worlds. Whatever they are finally saying out there, we are at last in the room to listen. Now, at long last, we can gather up everything the night has counted and set it all against the sheer size of the sky, softly without any hurry at all, the way you might finally lean back and take in the whole of a thing you have been walking slowly through piece by piece. We have found water and maybes all through our own solar system, and a world resting in the nearest star's comfortable ring, and crowded rings full of quiet twilight worlds around the common red dwarfs, and rocky cousins around stars much like our Sunday. And we have begun to read the very air of worlds 100 light years away. The pattern has held true everywhere we have thought to look. So the last question of the night is the very largest and gentlest one of all. If maybes are this common wherever we turn, how many must there be, all told, across the whole of the galaxy? Begin with the stars themselves, because that is where every world has to begin. Our galaxy, the great slow wheel of the Milky Way that we all live within, holds not thousands of stars and not mere millions of them, but something on the order of hundreds of billions, more stars than there are grains of sand along a long stretch of open shore. Every single one of them is a sun. Each one draws its own comfortable ring around itself, its own soft band where water might stay liquid. And what we have quietly learned, world by world, through all the patient counting of tonight is that a great many of those rings are not empty at all. Worlds are the ordinary companions of stars. It turns out, and not their rare and lucky exceptions. So astronomers took the patient harvest of the Kepler telescope, all those thousands of worlds, found around all those thousands of stars, and did the careful and unglamorous work of accounting for all the ones that must have been quietly missed, the ones whose orbits never once lined up for us to see. And from all of that, they drew out a single gentle estimate, one number meant to stand in for all the worlds we simply cannot count one at a time. Their study suggested that scattered through our galaxy, there may be something on the order of 300 million worlds of roughly our own size, rocky and solid, resting in the comfortable rings of their stars, in the soft band where water is allowed to stay liquid, 300 million possible homes, and that in our own single galaxy alone. Let that number rest lightly upon you now, the way you would let a slow snowfall rest, without ever trying to hold any single flake of it. 300 million is far more than a person could ever hope to count in a whole lifetime of counting. More than you could name aloud if you spoke a fresh name every second, without once stopping for 10 years together. And it is only the potentially habitable ones. Remember, only the rocky worlds of about our own size resting in the comfortable rings, and only within our own single galaxy, which is itself but one of an uncountable multitude of galaxies, spread all through the wider dark. The number is not really meant to be grasped at all. It is meant only to be leaned against. Softly, the way you might lean back against the sheer size of the night ocean. There is an old and gentle way of thinking about all of this, one sometimes drawn out as a simple chain of questions, a soft way of asking how many worlds might not only hold a little water, but actually carry life, and life that might one day, perhaps, wander quietly back at us across the dark. It multiplies the number of stars by the fraction of them with worlds, by the fraction resting in comfortable rings, by the fraction where life takes any hold at all, and so on, down a soft ladder of maybes, rung by uncertain rung. The honest truth is that we still do not know most of those middle fractions, and so the chain cannot yet give us any firm and final answer. But every year of patient counting fills in another rung a little more clearly, and every rung we have managed to fill has come back larger and friendlier than the old fears ever supposed. The worlds themselves are there in their multitudes. All the rest, patiently, is what we are slowly still learning. And our own galaxy, for all its hundreds of billions of stars, is only one among a great many. Beyond the Milky Way, out across distances that dwarf even the ones we have drifted through tonight, there lie other galaxies past any hope of counting, each one its own vast wheel of stars, each turning with its own hundreds of billions of suns and its own uncountable soft rings of possibility. The 300 million maybes we have gathered belong to our single galaxy alone. Multiply them by the galaxies, and the number leaves the reach of language entirely. There is no need to try to follow it there. It is enough to know that it climbs, and climbs, past anywhere the mind can go. So the honest answer to the question we began with is a soft and open one. And it is kinder than the old fears supposed. We do not yet know how many worlds truly hold life, and we may not know for a long while yet. What we do know is that the places where life could gather are almost without number, near and far, hidden and open, around every kind of star there is. The universe is not a bare and empty room with a single lamp burning. It is a vast, quiet field, sown thick with the makings of life, most of it patient and unseen, waiting in the dark. And that is a gentle thing to have learned, and a gentle thing to carry down into sleep. None of this asks to be understood tonight, only to be rested against. The count is not a problem set before you to solve, but a wide and quiet thing to lean on, the way you might lean on the size of the sea, without ever needing to measure it. You can let the numbers stay soft and uncounted, and simply feel their gentle weight, the sense of a sky far fuller and kinder than it once seemed to be. That feeling is the whole of what there is to take from tonight, and even it can be set down when sleep finally comes. The worlds do not need you to hold them at all. They only offer, quietly, to keep you company here in the dark. It is a rare and gentle privilege, when you think of it, to be alive at just the moment this became knowable. For every generation before this one, the question of other worlds could only be wondered at, never weighed. And for whatever generations come after, the count will be old and familiar news, a thing learned in childhood and taken for granted. Only right now, in this narrow window, is the wonder of it still fresh, still new, still being uncovered night by night. You happen to be resting here at the very moment the sky is first opening itself to us, and that alone is a soft and quiet thing to have been given. Here, quietly, is the turn the whole night has been drifting slowly toward. When we began, the old picture had us as the single green exception in an empty black room. And that picture could feel, on a long night, a rather lonely one to hold. But everything the counting has patiently shown us points softly the other way. The sky is not an empty room with one lit lamp burning in it. It is a vast, dark field scattered thick with maybes. 300 million of them in our own galaxy alone, small worlds resting in soft rings around countless suns, some of them remembering old water, some hiding whole oceans away beneath ice, some wrapped in an air we are only just beginning to read. We may not yet have found a single other living world anywhere, but we now know, past any real doubt, that the places for life to gather are very nearly beyond all counting. That is not a lonely sky at all. It is a sky full of quiet company, waiting patiently out there in the dark. So let the counting go now, gently, the whole of it. You do not have to carry a single one of those worlds off to sleep with you. Not the 300 million maybes, not the hidden oceans, not the soft twilight rings around the small red suns. They will keep. All of them have kept for billions of years, already without anyone at all to count them. And they will go on turning quietly in the dark, long after this night is over, needing nothing whatever from you. You can set every one of them down here, softly, right where they are, and let them drift on without you into the enormous patient dark that has always held them. We began this night far out in the dark, looking back toward a single small point of pale light. Our own Sunday, the one gentle hearth within reach of all these cold and distant maybes. And here at the very end, we come to rest against that same small light once again. Only now, we know a little of what surrounds it. Not an empty room after all, but a sky full of soft company, world upon quiet world, resting in the rings of countless suns, most of them things we will never once see and never name, all of them turning slowly, all of them patient, all of them together keeping the long dark from ever being truly empty. There is a great deal of company out there, resting in the same dark as you. A deep and quiet comfort lives in that, if only you let there be, and it asks nothing of you at all, but to rest gently inside it. Whatever you carried into this night, whatever felt heavy or unfinished when you first lay down, it is very small when held up against 300 million quiet worlds, and it can wait now easily until the morning without you. The sky has been keeping its uncountable maybes safe for ages, entirely without your help and without your worry over them. It can surely keep them a little while longer yet. While you sleep, let your breath slow and the far worlds turn. Allow the whole soft multitude to drift on in the dark, and let yourself drift down alongside it, gently into rest, held in the very same quiet the stars themselves are held in. If this slow drift among the worlds was a comfort to you tonight, it lives on quietly over on Spotify as well, waiting there for another evening when sleep is slow in coming, and there will be another journey before long, out towards some other far and quiet corner of the dark. But none of that is for now. For now, there is only this, the small pale light resting in the distance, the countless soft maybes turning around their countless suns, and you, safe among them, needing to do nothing else at all. The count is done. Those far worlds will keep. Rest now and let the quiet cosmos hold you. Good night.